The broadcast is now starting. All attendees are in listen-only mode.
Well, hello and good morning, everyone. My name is Jeff Mannion, and I'm the marketing director at Standard Imaging. And I'm also the product manager for Structure AI QA. And I'm very happy that you're here this morning to talk, to listen and learn a little bit about this wonderful new product by Standard Imaging. And so let's get started. Structure AI QA, well, what the heck is that, right? Well, first of all, let me just, let you know that it's actually a really simple little program to use. It's a desktop application that installs in a jiffy. Nothing too crazy about it. Anybody can install it. And basically what it does is it will compare two related DICOM RT plans and structured data sets by applying user-defined equivalence algorithms. The differences are scored and presented in a manner that allow the user to make decisions on the quality of one structured data set to the other. So what we're talking about here is, basically being able to compare, so I have, let's say, a set of CTs, great. And let's say somebody did a great job on contouring all these CTs, and here's the contour data right here. So I load that in. So great. Now I see all the contours. I see it on all the images, all the CT slices, and all of that. Fantastic. But then let's say somebody else or auto segmentation engine decided, hey, let's try it on that same set of CTs. So go ahead, it rolls through that same set of CTs and creates its own structure set. And now I'm going to load that in and kind of lay it over the top of my first one, and let's do a comparison to see how well it did. So basically, again, Structure AI QA works by importing pairs of volumetric anatomy data sets and compares them quantitatively and objectively using both standard and user-defined comparison techniques to generate metrics of agreement. The metrics act as a summary. The metrics act as summary measures to describe the, quote, sameness between data sets. Multiple and user-defined metrics allow clinicians to design them to suit their specific needs. So great. Let's talk a little. So why would I even need something like this? Move this out of the way here for a minute. So why is it important to you? Well, first of all, oops, there we go. Structure AI QA is a great tool for evaluating an auto seg engine before purchases. 5-10 years ago, auto seg engines were super new on the market, and they were just okay and all of that. But really, over that same period of time, they have improved a lot. And so, but then you have to say, well, which one should I use? And I'm saying that we should think about using Structure AI QA to do that help you with that evaluation. So let's say ideally what you would do is you get a temporary license from your AutoSeg vendor to try out the software. Structure AI QA is the perfect tool to organize and produce objective evidence. So for example, let's say is the Elekta model working the best? Is the Varian model working the best? Or is any of these other third-party companies that are popping up across the industry and doing really great work like Limbus AI or any of the other half dozen or so AI seg companies that are emerging? And what you would do is you'd say, well, let me try it, let me try the Elekta model against my gold data. Again, I take that same CT set. I've got the segments. I've already contoured this thing. It looks fantastic. This is a really well done set. And now I'm going to have an AI engine try it, and I'm going to compare it against my gold set. Again, it's a great way to evaluate an AutoSeg engine before you purchase it. Acceptance testing. So let's say finally you get down to selecting an AutoSeg engine, but now you're going to have to do some acceptance testing. And what I mean by that, it's something you want to make sure that you understand the tool really well before the AutoSeg engine, before you actually start using it clinically. So let's figure out, so where do we trust it and where don't we trust the new AutoSeg engine? Like, does the AutoSeg engine do well on certain organs of a model, but maybe not so well on others? As a user, you're going to have to try to make those decisions. It's extremely inefficient, to just look at the results and, hey, is it a thumbs up or thumbs down? Is it okay? That kind of thing. And just by kind of scanning by eye, it's not scientific. It doesn't lend itself to automation. And it's very inefficient and subjective. Structure AI QA provides quantitative analysis that you can rely on. And I'm going to show you that in just a few minutes. So again, you buy a Structure AI QA as a way to evaluate an AutoSeg engine that you're thinking about purchasing. Number two, you're looking at, once you buy one, you do some acceptance testing, and you can see, like, oh, it seems to do really well on the left and right parotid and all this other stuff, but for some reason on the spinal cord, it kind of misses or it overshoots or something like that. Not to say that it's bad, but just know that, oh, I have to be very careful moving forward when I'm doing a specific region of interest, because this AutoSeg engine tends to either overcompensate or undercompensate or something. Vendor updates. So another reason for getting Structure AI QA is when your vendor provides update. The AutoSeg engines updates are going to be becoming much more like DOS engine updates, but much more rapidly. It seems like every other month you're getting an update, that kind of a thing. They're going to be changing continuously and releasing updates. Things like, hey, our model 2.5 now includes the small bowel, or it could be that an existing model has more organs, and it may be that the new model, for a new body type or for a new model to support a new image modality, now we have head and neck for CT, and we just released MR for the brain, or all of that kind of stuff. And so what you want to do is you want to do what's called regression testing. You want to go through all of your tests again, like your acceptance tests, and see, yep, look at that. It did some improvements here. It used to be kind of off on this region over here, but now it's even better. Oh, and now it's now doing this new region that, like it said. Or sometimes what happens, because I've been in software a long time, things break, and all of a sudden you go, well, wait a second, I love what you're doing over here, but it used to do, the left and right parotid really well, and now for some reason it's not so great. What's going on with that? So now if there is a problem, you can go back to your vendor and have that conversation with them and show them the data. And so, hey, I've been doing this for a while, and here's my goal set. I ran it against my goal set, and yep, you did some definite improvements here, but in the old version, this was a lot better, but now for some reason it's off. Can you help me out here? So again, you can use it for evaluation, acceptance testing, and vendor updates. But why is structure important to the administrator? Well, of course, some of the obvious things, ensure safety and accuracy. AI, deep learning, auto segmentation technology emerging and promising. Widespread implementation is imminent. Verifying the accuracy of auto segmentation in an objective and rigorous manner is, well, it's paramount. Make data-driven purchasing decisions, just like I mentioned a moment ago. To try it before you buy it, and you can look through many different AutoSeg engines and see who's giving you the best results based upon what you're seeing in Structure AI QA. implement an efficient and reproducible validation process. Just like you must, validate and commission dose calculation algorithms, you also need to validate and commission your auto segmentation models. You'll need to do this not only initially, but as new models evolve and new models are added, different body sites, new modalities, and just like I mentioned before, Structure AI QA, that process is efficient, comprehensive, and can be automated and reproduced either singularly or via this batch analysis functionality that I can also talk to you about just a little bit later. Again, like I kind of mentioned before, communicate better with your AutoSeg vendors. And again, if you're seeing something wrong or seeing a change and you're not quite sure what's going on, you can show them the data. You can show them what you're seeing, and that's worth a lot. And actually, at low cost, you'll find it. When you talk to your sales rep, that it's actually a very, very affordable little product. So let's get on with a demo here, and let me get right to this right here. All righty, and so I'm going to start from the very beginning, actually. Hang on just a second. Let me clear all this. Clear all. Yep. There we go. So what you got here is Structure AI QA. Simple little Win32 application. It's a desktop application. Doesn't require any special craziness in terms of getting IT like reams and reams of things to do or anything like that. I'm sure IT is going to want to know about it, but they're it's pretty vanilla when it comes to like installation type stuff. So what you do here is you're going to load the data up. This little dialog pops up, and let's go and take a look at that CT set. So let's bring that in, and there we go. And it says, oh, this is what I found. Very good. And so now here we're going to select what we call the primary structure set. This would be what we would probably call our gold standard. Maybe this was done by like one of our best stoichiometrists. This is a really good set of contours. It's all set up. So we load that in. Great. And it says here, okay, here's what I found, and here are all the structures that I found. And these, of course, all this kind of information you'll see in your DICOM file. And then I'm going to bring up my secondary structure set. This was the one that was, let's say done by somebody else, maybe as a training exercise, or certainly with an AutoSeg engine. And it tried its hand at those same set of CT images. So yeah, bring that up. And it says, yeah, this is what I found in the secondary set, the one I'm going to compare against. And also here are the regions of interest that that I matched with the primary set, and see that I found them all. It looks like, yep, and all 16 of them. We're going to talk just a little bit about that in a minute on how it finds it and some of the neat things you can do to make sure that because sometimes things are spelled slightly different in DICOM files, and so it's like left parotid, L parod, underscore left, that kind of thing. It may not find it, but in Structure AI QA, you can build in some real nice things so it does, can find the two against each other. So we're going to load the data, and there we go. So what do we got here? Let me just take a second here and take a look at the screen. Here we have this kind of like view from the 10,000 foot level. And as I move the center line here, that's basically going through the slices. You can see that, okay? There we go. So we have that. This region of interest box here, these are all of the regions of interest that structure found that were common between the two structure sets. Okay, so here they all are. Here is your basic image adjustment piece, window leveling, if you will. You can play with that to your heart's content. And over here we have the main screen of the CT slices. Now you'll notice here that we've got some lines going here, and basically if you see a solid line a solid line, that's your primary set. That's your gold set, that either done by your best dosimetrist in the whole wide world or something along those lines. So you're all set with, you know, those solid lines. Of course, they're color coded to match the different regions, or to be able to recognize regions more easily. And then the dash line, that represents what the secondary structure sets brought, you know, found, meaning one that was done by either another human being or an auto seg engine. So those are those right there. So we want to now do some calculations, you know, doing we want to see the comparison in data in a data form, you know, in metrics. And basically what we're going to do here is we're going to use some very standard metric algorithms that you'll see in just a moment. And also too, we're going to apply our own user-defined scoring system. Let me just take a peek. Before we do that, let me just show you what that means. So in settings, we go to metric preferences, okay? And basically what we have here, this comes out of the box, the default linear. And it says here, you know, if I find that they match perfectly, you know, there's no what we call penalty, okay? That's fine. However, if I start to go beyond 1 millimeter, you know, like where the two don't match, like here, let's take a quick peek here. See these two here? It's pretty darn clear that there's clearly they're not matching a whole lot, okay? And so if they go beyond 1 millimeter, I'm gonna start to penalize it here, and I'm gonna penalize it even further, just a linear, basically a linear curve, you know, all the way out to 10 millimeters. So both, meaning I've overshot here and I've undershot here, meaning let's say there was a region, and you know, and if I'm off here on this side, meaning I'm way too small, or I've really, I don't have near the area that the gold standard did. Here I'm exceeding the area of voxels beyond what the gold standard said. So again, just we'll get into this part, you know, another time, but just here's our default linear. So what I have to do here, and because I just didn't have the time to put this together before we did it, I set all of these to default. Give me just a moment here. And then if you had other ones that you can add your own, by the way, and I'll show you how to do that in just a minute. You can put together your own scoring system, you know. In fact, here, let me show you that real quick. Yeah, there we go. So back to here just for a second. So if I bring this up and I want to add another one, you know, then I could, for example, put this in and this in, for example, and, you know, things like that, you know. And now I've got a new way of doing it. This kind of crazy way, but, you know, a new metric method that I could use, my own little scoring thing. But I'm not going to bother with that one right now. So here I'm ready to go, and now I'm ready to calculate. So hit the calculate button. Look at that, we got progress right there. And now you can see where it's all kind of shaded in. In fact, I'm going to take this little opacity tool here, and I'm going to brighten that up so everybody can see that real well. Take a look what we got here, just from a visual standpoint. Here's a really good example. Where it's green, that's where the primary and secondary set we had common area. Meaning, yep, we both agree that here is the region of interest. If it's blue, that means that the primary set, our gold standard, said, yeah, and actually the area of interest goes all the way out to here. But for whatever reason, the auto seg engine missed it. Didn't realize it went out that far. And so here, meaning it undershot, or it's cold. Blue is kind of cold, if you will. On this particular example, again, green means, yep, this is where we agree. But, you know, on the brainstem. And so, but then here, it's the secondary set, or in our example here, the auto seg engine. actually overshot this area. See what I mean here? It's like undershot, agreement, overshot, agreement, all of that. But that's just a visual representation. And again, we could kind of go through this, and you can see different, you know, as we roll through the CT set. Yep, oh, look at that. Yikes. Yeah, you know, on and on and on. So let's put this back, and now what I can do is I can go now to our actual metrics here, and let's just talk about that just for a second here. And again, on the left-hand side, you can see here are the regions of interest. They line up with this region of interest over here, and I can, as I roll through them here, just, you know, selecting each row, the histogram below and the data will update to reflect that particular row. Yeah, let's take a look at one here. So in this particular one, this what we have here is, you know, they go along the top. We say here in volume 1, that's our gold set, you know, we found, you know, 172.520 cubic centimeters. You know, this is what we found. In the AutoSeg engine, it found this much volume, or, you know, voxels, if you will. Here's what's common between the two, and here's what's missing, like the blue, or what's extra, the red. We do a dice coefficient, and then we say, here's the max difference. And here, this little funny, you know, colored area here, that's our, you know, our own little scoring system that we put together. Maybe back, if you recall back to this thing again, you know, this part here, this relates to all of these metrics on the side here. And so, you know, yep, it has a score of 100. You know, we're saying, you know, if it's within 1 millimeter, the difference, gold, man, that's great. You know, even up to 2, it's still pretty darn good, you know, that kind of thing. Or, you know, but then as we move down here, let's go down to this optic nerve here. Oh, look at this. You know, we do have quite a bit of extra, right? Or, you know, over here, and our scoring was pretty lousy. And let's take a look at our histogram. Sure enough, we have good agreement here, but gosh, a lot of extra overshooting in this particular area, going, you know, 1 millimeter out, you know, meaning in the extra, you know, I've overshot metric side of the equation here. Quite a bit here too, quite a bit actually on the undershoot. And then of course you can get to some really bad ones here. The optic chiasm is, you know, they didn't agree at all anywhere, and had all kinds of problems, both undershooting and overshooting. Over on the right hand side, again, it's a whole breakdown, a lot of the stuff that you see up here, of course, and you can copy and paste this. This is basically a CSV file. You could just copy and paste this into a spreadsheet if you'd like, and you know, play with the numbers to your heart's content. And again, so you have it, you can switch between the views up here. You can also switch up here to this little thing right like that, all these little tabs. And there you go. And if you'd like, you can create a, you know, full report, a multi-pager, just maybe a one-pager, boom, you know, just kind of put together, and there you have it. Let's see here. Let me just put that away. Okay, so what we saw right there was a way to put together, like kind of like, you know, one at a time. You know, hey, I've got a CT set, I got my gold structure set, and I've got one I want to compare it against. You know, or you know, and my AutoSeg engine, let's say. I can do that one at a time here and put together reports. But sometimes, you know, you'll have many segmentations, or, you know, sets that you want to evaluate. You can do something called a batch analysis here. And I won't go through the whole thing, but there it is, right, like so. And basically what you're going to do is, here, let me just go back to here. And basically what you're going to do is you put together a spreadsheet, okay? And basically it has the path to, you know, the data sets as what the primary data set, the secondary data set, and the CT image. Actually, not even the CT image, just the data sets. So the first and second. You really don't need the CT sets. The CT sets are just there for human beings when we look at it through the GUI, so that we can make sure that we're all oh yeah, that's with that one, and I can see everything very nice. But really, at the end of the day, we're just comparing structure sets. So what you do is you put the path to each your primary, secondary, primary, secondary. You can do that for hundreds of these things. You would then load that into structure right here. Batch analysis. You would go ahead and load that. And then the engine behind it would then grind through all of that stuff and then spit out a new CSV file or spreadsheet. And then here, you can look along at the top here, here's all your metrics again, just like you saw, right here. All of that is right here again. And even more data, basically everything that you're seeing along here. Yeah, lots of really good stuff. So if you wanted to do, and then if you wanted, you could use Excel or something like that to put together nice looking graphs and all of that sort of thing. So that's a very, very handy tool, especially if you're going to be doing just a whole bunch at once, and it just takes moments to do, and voila, you're off and running again. So Structure AI QA, it's a great little tool. It's inexpensive and easy to install and to set up. And again, why do you use it? You use it because you're looking to buy an AutoSeg engine, and you want to kick the tires on it. You wanted to, here's a great little CT set and a structure set that goes with it. I'm gonna have the AutoSeg engine try it too and see what we get. That way, again, you could try many different AutoSeg engines and get a good feel of what you like the best. You use it when you're doing commissioning, and that way you can get a real good idea on where does the new AutoSeg engine do really well, and where maybe not so well, or gee, it honestly just failed right here. And then third, anytime there's updates, and because once there's updates, you can then check it again. You can do your acceptance testing, and also if you're finding something along the way, you can go back to your vendor and show them the data that you're seeing in their AutoSeg engine. That concludes my webinar for today. If you have any questions at all, don't be afraid to give me a ring, either at sales@standardimaging.com, or if you want to just get to me directly, it's jmannion@standardimaging.com. And thank you all for being here. I hope that you have a great rest of your day, and happy holidays to everyone. And hope to be hearing from you soon. Thank you very much, everybody. Goodbye now.